Tesla found out a way to get out of space and connect to another dimension. And Alexanderson figured out a way to circumvent space completely, or his work implies that you can circumvent space completely and make things appear in one other part of the universe without anything time delay in between. So now the next thing is not only the light bulbs, but now they had the idea of these telegraph relays. Now they got these things spinning in the form of motors. Edison started developing giant telegraph magnets into motors. The famous Edison motor is two very long solenoidal coils that stand almost 8 feet high, and then there's a rotor down in the bottom. You have these large electromagnetics, and what Edison had done was basically just amp up the telegraph magnet, because that's all there was to work with at the time. So this is where Nikola Tesla comes in. So Nikola Tesla comes to the United States. Okay, he's almost turned back because he doesn't have any money. But he has one thing that gets him in. He has a letter of recommendation from the Edison Electric Company in France, if I remember right, either France or Hungary. And Edison lets the guy in. So Tesla goes off on his rotating magnetic field discoveries and all these things, and Edison just looks at him and is not interested in any of this stuff. What Edison wants is Tesla to work on motors. So Tesla, because he's already starting to gain a conceptual knowledge of how this rotating electrical thing's supposed to work, points out to Edison that these big telegraph coils are foolish, that the coils are supposed to be wrapped inside the motor. And Edison said, if you can develop that, I will give you $25,000. So needless to say, Tesla went right to work on it. And in a short time, he had developed the present-day direct current motor, which is basically a square block instead of a tall column, and it later became rounded off. So it turned out to be a great success, and Tesla didn't get a dime of his money. So Tesla left and was digging ditches on the street until some Western Union people came by and wanted to know if he would work with them on some of their projects, and he worked his way up, and he worked his way up. And Tesla decided what he was going to develop. He was going to come up with a motor that didn't need all the sparking and rigging and all the real fine wire on the coils and all these complications. He was going to eliminate that up and come up with a perfect magnetic whirlwind, where the rotor would spin in the ether with no contact on it whatsoever by setting up a magnetic vortex. But there was no way to conceive such a thing at the time, because basically everything in electricity was a positive, negative reality, so you couldn't make anything spin, because it could either just go back or forth. And they fought and they fought and they fought, and there's no way. You had to have the commutator as the carrot in front of the horse to trick the field. What the commutator does in the motor is the windings come around, there's a switch. And what it does, because the windings only can turn so far before we want to be pushed back in the field again or get stuck, the commutator switches in the next set of coils as the rotor turns around. So it creates this kind of phantom thing where the coils are always trying to go towards something, but then they get disconnected in the previous batch. So it's like a lineup around the thing. It fools the motor into spinning, but this thing throws off all this dust and sparks, and it's problematic in maintenance, and the motors are horribly inefficient because they have to have these big magnet coils with lots of current flowing through them. So Tesla fought the problem in his head, and everybody told him it was impossible, and he was an idiot for even trying. Think about it. So Tesla was reciting some poetry one day, and then watching the sun go down, and then had this idea, because of the poem he was reciting, was talking in such a fashion that if the sun's going down here, it's got to be coming up somewhere else, and got the idea of the quadrupolar polarity, where you have two plus and minuses at right angles to each other, and you switch them. So what Tesla developed was a way to make alternating current carry around, just like the phases of the moon. And drew the whole thing out in sand. The thing appeared in a flash in his mind, and everything was invented at that point. Because Tesla could go into visions so intense that Tesla was renowned for building motors in his head and running them for months to see the rate of bearing wear. So you're not a normal individual. So we can only imagine what went on in his head. So Tesla worked with this and got it developed, achieved. Nobody seemed to want it. And Edison got really upset about the whole thing. So Tesla's about ready to give up on it. He meets a guy by the name of George Westinghouse. George Westinghouse made parts for railroad trains, mostly the brake system, the Westinghouse Brake Company. Okay, now some of those brakes are magnetic. So he was already geared up for coils and solenoids and things to actuate the brake mechanisms. So Westinghouse decided he had enough money, he was going to support Tesla, and they were going to make this thing and make it work. Well, Edison didn't like this at all, so Edison turned into the gas companies. The very thing that screwed Edison. Edison repeated the whole process and delivered it all to Tesla. So what Edison did is Edison started getting reject circus animals, hiring kids to gather up dogs and cats off the street, and he would have them Westinghoused on stage, which was about 2,000 or 3,000 volts of alternating current, about several amperes. So he had to have a big machine somewhere to produce this, but that never really showed up in any of the old pictures. But what did show up in pictures was elephants just crumbling to the ground with smoke shooting out of them. So we're talking about 50, 75 kilowatts to do that. The electric chair is 5 kilowatts. So you hook up a big slab of meat in the oven, you usually got to have about a 5 kilowatt cooker going for a couple hours. So that gives you an idea how much juice it is they put through the body. So Edison invented the electric chair using alternating current in order to put Tesla out of business, and then started spreading these stories of the fantastic dangers of alternating current. So Tesla was getting rocks through the window and the whole deal, and he's trying to push all this forward. But Tesla really pulled a good one on him. Okay? At this point, Tesla had already invented all that motor stuff, and he was onto something even bigger, even more fantastic. So he wasn't really worried about a lot of things other than just getting his money. So here's what Tesla discovered. Tesla discovered a completely new type of electricity, unlike DC or AC. Another type of electricity. It's called impulse electricity. This impulse electricity behaved in a fashion that was completely extraordinary. It was getting back into the ether electrical concepts, because what it would produce would be so bizarre that it almost looked like the aurora borealis appearing around his coils. So what Tesla found is this type of electricity, rather than being damaging to the body actually seems to benefit from it. So Tesla was destined to give a demonstration of his more recent researches. He was already famous for his motor. Okay, and Steinmetz was already put in business in order to mathematically analyze the Tesla system, so that General Electric could defeat Westinghouse in the Tesla patents. So that's how Steinmetz got basically started in the thing, and Tesla built all this stuff in his head, and he left no engineering math. He didn't need any of that. So there's no way that other people could duplicate his devices, because there was no engineering. You didn't know how much iron to use, you didn't know how much copper to use. People would try to use these motors, and for some mysterious reason, they would just keep burning up. And it was Steinmetz was the one that discovered why. And that made him famous and put him in his lifelong position as the founder and director of General Electric Research Laboratories. So Tesla devised his vacuum tubes and his transformers and all the things that technology that he developed with this impulse electricity, and gave a presentation in Europe. And it was so fantastic that Tesla was immediately a worldwide hit, not only as an electrical scientist, but as a magician. What Tesla had accomplished, which nobody's been able to duplicate to this day, is he connected himself to these devices that he packed over there, closed the switch, and how many people know what a neon bulb is? You know that the funny glow that covers the metal electrode? It's like a fire, but it's not really a fire, and it kind of looks like a jelly, but it's not really a jelly, but it's the plasma, the glowing plasma in the neon bulb. Tesla's whole body lit up like a neon tube cathode, on stage, without a burn or a mark on his clothes. And then he pronounced, "Here are the dangers of alternating current," and laughed. So that ended the whole DC-AC controversy right then and there. Plus, J.P. Morgan needed to make money off of it. So nothing could stop it at that point. So it went. And Tesla kept pursuing this technology. So what Tesla found is Tesla came up with a situation that kind of defeated the whole physics end of the electrical engineering world, and that's basically why there's no knowledge or information on it, because it's just completely blocked off. These things are impossible. They can't happen. But, you know, you build Tesla's devices as he prescribes in his writings, and you will get all these effects. I've duplicated just about every Tesla experiment. In fact, actually, I'm very famous for being probably the only person that has ever duplicated Tesla's experiments. And it's not because I'm smart or that I talk to space aliens. What it is I don't make any improvements on the historic study. It's that simple. I just do exactly as instructed, and it all works exactly as described. So Tesla had come up with a way, with this high-frequency experimenting and the mechanical analogs that he developed to go along with it, to defeat the action-reaction law, or the Newtonian law, where every force has a counterforce. Tesla came up with a way to produce a push without having to lean against anything. He did it both electrically and mechanically. So what Tesla found is that similar devices that operated on the same frequencies or rates would communicate energy between each other. So what Tesla did was basically, at that time, discover radio. But the thing about Tesla's radio that's different is there's no real energy loss between the two devices. In other words, you can transmit from one device to the other, and there's not, it's like there's nothing going on in between. It goes right to the receiving device. The electrical meter doesn't start spinning at the transmitting station until the space heater is plugged in at the receiving station, and there doesn't seem to be anything measurable going on in between. And Tesla's aim was to produce a worldwide power system that was based on this principle, and the power system would be tuned to the natural resonant frequency of the Earth, and you could just simply disconnect all the generating stations, because the solar system would run the electrical plant. It would be one with the electrical system of the Earth. So what Tesla had to do is he had to do an experiment in Colorado to prove if he could resonate the Earth and make it take off. And it's too bad in that day and age there weren't videotape cameras, so somebody could have got documentation of what this guy must have unleashed. So what Tesla did is he had figured out the frequency of the Earth, or the harmonic that he could use, which he started working at about 80 kilocycles, and eventually he worked his way down pretty close to 50 before the thing was all tuned up. It was a transformer that had a coil 50 feet in diameter. The output terminal of the thing was on 100 and something foot, at least 100 and something foot mast. And the idea was Tesla was going to send an electrical pulse into the Earth. It would bounce off the inside of the Earth and come back at a certain time with a certain increase or decrease in energy level. And he was going to continue this process, you know, in microsecond groups as these 50 kilocycle waves are echoing in the planet, until what he would produce, it would be a giant electrical fountain of the Earth's activity at that point in Colorado, which is kind of a place where it was safe to blast because nobody would get hurt. The elevation was good, and this is the place he chose to do it. So when Tesla closed the switch, after all the experiments and tests, he produced for a period of about maybe 1 minute a standing lightning bolt at the terminal of his giant transformer in the building that contained it. Not just one pop, almost standing lightning bolt, modulated at about 5,000 cycles a second from his capacitor discharge switch. So the sound must have been something that was unfathomable to describe. Tesla succeeded in concentrating the entire electrical activity of the Earth into his station in Colorado. So he packed up his bags and moved back to New York. And Long Island began to build the final station where this was not an experiment. It was something that worked. So he could start applying it to electrical transmission. Okay, well, in 1900 is when Tesla completed those experiments. And then by 1903, he had managed to get the money from J.P. Morgan to build a permanent plant in Long Island in New York. And then about halfway through the construction, Tesla was dragging his feet and spending too much time experimenting. And Morgan got the idea that this was going to be a self-powering system and just cut Tesla off at that point. And he was blackballed. He couldn't get any money to do any projects after that.
Threw him out on the street, so to speak.
So to speak. Yeah, I mean, he had enough rich friends. I mean, he used to wine and dine with the royal elite of New York City. There was nothing that the elite would want more than have Nikola Tesla for their dinner guest and have the opportunity to get a demonstration of his laboratory after dinner. People came from all over the world. Kings, queens, everybody. Everybody came to see Tesla's laboratory and have dinner with him. So 1903 to 1905 would be the period in which Tesla became a nobody.
Wow.
And he died in 1943. So that's kind of a long sentence as a street person. The whole idea is to recreate the mind of the people that invented all of this, is what I'm trying to do. And then, each person can fit it into their own, analogous, business or understanding or whatever. So Tesla basically, this was about 1903. Around then, Tesla was promptly put out of business. And as far as overall history goes, he spent the rest of his time as a homeless person, feeding pigeons on the street. And all the rich people that, he made rich and all that, basically just always made sure he had a place to take a shower or a hotel room. And so the world's greatest electrical genius spent nearly the entirety of his adult life feeding pigeons on the street in New York City and hanging out in the library. So that's the end of Tesla. But we still got Steinmetz. Okay, now Steinmetz has taken the heaviside mathematics and developed it into an extremely powerful analytical tool and engineering tool for electrical work, and is doing things in the laboratory that are basically beyond conception. Steinmetz even has a reputation for building a time camera. So Steinmetz wrote a book in 1900 called The Theory and Calculation of Alternating Current Phenomenon. That immediately made him world famous. Steinmetz found out why the AC motors were burning up and heating up and developed what's called the law of hysteresis. The law of hysteresis is a situation where cause and effect no longer have a direct relationship. They're separated from each other. And through a hysteresis cycle, energy can appear or disappear into alternate forms. And basically, the internal combustion engine in the car works on a hysteresis cycle. The refrigerator in your house works on a hysteresis cycle, in that the cause and effect relationships are altered so that energy is transformed from one system or one state to another. What Steinmetz found is that when you have current applied to electrical system to force magnetism into existence, the rate at which the magnetism develops is not the same rate at which the magnetism dissipates. And the force and the forced deal don't tie together anymore, and they don't happen at the same time. And what this does is it causes a massive loss of energy. So Steinmetz had to figure out a way to work with only magnetic materials that didn't have the hysteresis effect, and to laminate the iron instead of using blocks, so the magnetism wouldn't be shoved into the metal, but rather be guided by it. And lo and behold, the AC motor was entirely engineerable and possible without Tesla and without Westinghouse. And alternating current flourished at that point. So Alexanderson developed, based on the Marconi system, another type of radio. Now this radio is not really clear how this one works. This starts to get into the fringe area of radio propagation. The net result that's implied by the way the system is laid out, where Tesla's system kind of drills a path from one place to another and doesn't spread out, but there's still electrical lines of force of connection. The Alexanderson system seems to be kind of a prelude to a situation where electricity will disappear in one physical location and reappear in another physical location without anything going on in between. In other words, a true action at a distance. And as far as like the conspiratorial or Etherean go, I would go so far to say that two properly constructed devices based on Alexanderson's principles, if you have one antenna in San Francisco and you have one in Los Angeles, and everything was tuned up right, that if you were standing in the one in San Francisco, you would be simultaneously standing under the one in Los Angeles as long as the generators were running. That is the implication of that particular technology or engineering, and that's what makes it worth studying.
Could you comment if you wish that the Philadelphia experiment might have been a variation of that?
Well, see, the Philadelphia experiment I don't know about because that's not there. You know what I mean?
I understand.
But yeah, the Philadelphia experiment would have to be, it would be something similar to that, but it'd be more like that integratron. What it is what Alexanderson had done was to figure out a way to make an electric structure that is what's called scalar. In other words, there's no variation in space. If the structure, the switch is closed, the thing's turned on, if there's 100,000 volts at one end of the antenna, at t equals 0, at the other end of the antenna, the 100,000 volts is still at t equals 0. There's no time delay for the wave to get from one end to the other. It can be completely neutralized. Now, the first place this was done was in a place called Bolinas, California, which is not too far away from here. This was the first full implementation of the Alexanderson principle to completely neutralize the velocity, because the velocity in the Alexanderson system is engineerable. It has no relation to the velocity of light other than infinite velocity and the velocity of light are two what would be called poles or zeros in the system. In other words, they're kind of like nodal points where it crosses over from one state to the other. This is what I use for my earthquake research, is I come up with an antenna that receives out of the ground in such a way that the interfering currents flowing around can't affect it because they have a velocity. The antenna has no velocity. It all responds instantaneously, so it only responds to what comes straight up out of the earth and not what's moving around in between. It could be presented another way, is you're presented with an engineering problem where you have 1 mile of ground rods with a spacing of 300 feet. What kind of transmission structure is going to connect those ground rods together so they're all operating instantaneously and one isn't late or early with respect to the other? That's the basic engineering problem. And the Alexanderson principle and the Tesla principles are the way out of these things. Now, what Tesla had done inadvertently is Tesla had created a situation where instead of plus or minus in his motor work, now he created 4 poles instead of 2. So you can't use plus and minus in its simplest form anymore because now you have 4 instead of 2. Let's kind of get into plus and minus a little bit and see what all that really is all about, rather than something you just heard somewhere when you were 12 years old. Okay, basically, all we can do is add with our fingers. Every other mathematical concept has to be derived. As primitive organisms in this world of mathematics, we count, okay, which is a process called addition, okay, which is symbolized by the plus. Okay, so if I have one item and plus another item, I count 1, 2. So 1 plus 1 equals 2. This is something that's innate in our kind of just, animal reality. Now, where Steinmetz comes in is how we work our way out of these type of situations. So the thing is what Steinmetz decided is being that we can only add, because we're primitive creatures, if we want to subtract, we have to use what's called an operator to evoke subtraction. So what Steinmetz did is you take a minus 1 and you multiply that by 1. And if you add that to 1, then you have subtraction, or 0. And he called this an operator. So now not only, being that 1 has no real existence in the quantitative end of it, we can just say now we have the concept of minus. So he's introduced now the mathematical concepts of plus and minus. Okay, and the way we derive these type of equations is we take 1, okay, and we take what's called the square root of it. Okay, or we take 1 to the 1/2 power. And this gives us plus 1, as most mathematicians would know right off, and minus 1, because the square has to have 2 roots. So what Steinmetz decided, let's just keep carrying this on so that we can get Tesla's 4-pole electricity into equations. So Steinmetz decided, let's go fourth root of positive 1, which has to have 4 roots. So you end up with 4 roots. You end up with 2 that are the square root of 1, which is plus 1 and minus 1. And you have 2 roots which are the square root of negative 1, which is plus j and minus j. So now we have 4 polarities rather than 2. We've scaled it up. This is what Tesla visualized in his visions in his mind, but Steinmetz turned it into a very simple algebra. There's no sines, there's no cosines, there's no trigonometric functions to deal with or any of that. It's a very simple algebraic situation. Now what Tesla did when he moved from the alternating current to the impulse current, okay, I'm going to have to define these things now. Okay, in the telegraph days, we have what was called continuous current from batteries. In other words, as time moves forward, if we have a device which basically measures the current, it's always the same. It's always constant. Okay, and the chemicals as well as the ether move in the direction of the current and gives us the false illusion that the wire is carrying the current and not the ether in the space between. If we take an electrical condition, let's see how I'm going to go about this now. Okay, well, I'm going to stay with this. Now, if we take this current, okay, what Tesla worked with was alternating current. So now with alternating current, what it is in a constant, where this current is constant, alternating current is in a constant state of change. So that can't really be represented by a line anymore, but now it's represented by a circle, okay, which continuously moves. Okay, and if we take projections of this circle, we find that there's one piece of the wave, one plus minus type of situation, that produces a kind of sideways spiral, which is known as a sine wave. Okay, but the thing is we're dealing with a circle. So what it is we got this other wave, okay, and it's moving in a contrary, conjugate type of situation. So at every time, the current's not 0, but there's another one to back it up, and they just keep going around the cycle, and that's what makes the motor turn. We start off with plus 1, and then 90 degrees later, plus j appears. And then 180 degrees later, minus 1 appears. And then 270 degrees later, minus j appears. And then 360, we're back to 1. So that the piece of iron inside the motor doesn't have to be connected to anything, because now it's just simply following the magnetism around. It becomes the perfect electric motor. Now, what Steinmetz shows is if we take this direct current, okay, and we open the switch. Okay, the big problem in electrical engineering in the beginning is when you open the switch, when they built the big substations and the transformers and all that, you can't turn the electricity off. It'll blast. So now Steinmetz had a new job. Why was everything exploding? First he stopped it from cooking. Now it's exploding. When they got the power level high enough, well, it turns out to be that the magnetism and the dielectric fields have stored energy. And if it has nowhere to go, it will blast a hole to get there. So what it is when you turn off the electricity, if it's pretty much in a direct current circuit and it's not much to store electric fields like coils or condensers or just light bulbs, what it is the current has to change at some rate. It has to move. It has to go into another direction. So what you get is you get what are called transient currents or impulse currents. You get these little jolts and changes as things are trying to readjust. So if I have a current, okay, and then all of a sudden I switch that current, then I get like a spike, okay, and that sudden rate of change is like an electrical impulse. It's not an oscillation or a cycle. It's not continuous. It's a quick change from one step to the other, and the whole electrical system has to readjust to this. So usually what happens, being that there's so much stored energy, that it starts in an oscillation, where the energy has to go between the various forms and bounce back and forth to try to get out, and it produces what's called an oscillating current, where the sine waves now are compounded with this other dampening wave, and it produces oscillating currents. Now these type of currents no longer have frequencies in the conventional sense. This has no frequency, DC. This has a constant frequency, an RPM, which we call cycles per second. But this has a different type of frequency in that you find that these curves, just like these curves always move in a sinusoidal form, these curves always move in an exponential form. And it turns out to be the same exponents that are associated with things cooling off or leaking or any type of dissipative type of phenomena. It never occurs at a constant rate, but it occurs like gravity on a rate upon a rate. And it also is a frequency of types, but it would be called an imaginary frequency. And instead of being in cycles per second, it's what's called in decibels per second. Now the generalized electric transient will be some combination of those and will produce this complex frequency. So these things were all running up and down the transmission lines and getting in the transformer coils and motor coils and starting fires, and sparks would just jump off of the lines and hit people for no apparent reason and blast them out of existence. It was a real problem. So Steinmetz wrote his second book, The Theory and Calculation of Transient Electrical Phenomena. And out of this book emerged this understanding of electricity that is so far in advance of anything today that it's just mind-boggling what this guy had discovered. And this, again, is what Alex Anderson had to work with in the development of his radio. Now, what Tesla did is, in using these impulse currents and oscillating currents in his engineering, Tesla came up with another type of polarity situation where there's only one pole. That's it. In other words, it's not even the square root of 1 anymore. It's the 1 root of 1, which is just 1. There is no plus and minus. Tesla came up with an electrical device where he could connect it to something like the Earth, and it would create electrical movement in the Earth, but it wouldn't have anything else to connect to. It was a one pole. It was just simply a plus. There was no negative. There was no return circuit, because the situation is like I explained, if you're going to transmit electricity or receive electricity out of the ground, you put in 2 ground rods in the Earth, okay, and you connect these to a battery. The telegraphers tried it, and that's the first thing they found out is most electricity just goes between the ground rods. Now, if I make that alternating current, well, it's just going to be the same thing. I can make a quadrupolar alternating current, then you got 4 ground rods. All it's going to do is spin around inside. So the problem is how are you going to do something where you can transmit into the Earth and not deal with the circulatory effect? So this is where Tesla's researches and writings and work are most important, is how did he accomplish this? And the implication out of this is the existence of another space called counter space. Shortly after these things started being developed, a guy by the name of Rudolf Steiner started to come up with a way that the mathematics, him and his followers, would get into this what he called a counter-spatial situation. In other words, now there's not just one space, but there's 2 spaces. And it's very similar to this addition and subtraction situation. Now, the thing that makes electricity so interesting, and we're studying, is the fact that electricity, and always being a 4-pole situation, exists in never any less than 2 dimensions at one time. There is no electricity unless you have magnetism and you have dielectricity. Otherwise, it's just magnetism and dielectricity. Until the 2 are united in some type of geometric configuration, you do not have electricity. So what Tesla had done was with electricity now, mathematically, electricity gives us a situation where we have to have plus 1. In other words, we have to have 1 multiplied by positive 1, where we have negative 1 multiplied by positive 1. So it gives us our positives and negatives. But now in another situation, we got this counter space situation. Now we have to figure out how to express that. Well, now we got 1 to the plus 1 power, and we have its conjugate plus 1 to the minus 1 power. So now we have taken a step from addition and subtraction to now we have multiplication and division, which is a more compounded, abstract type of process. And it's always in a logarithmic form. It's not in a linear form. It's not additive. It's compounding, cumulative in a certain sense. It's a situation like 1, 2, 4, 8, 16, 32. It's that type of situation. So what electricity implies, if this is our spatial, because multiplying is usually your spatial deal, where addition subtraction is your time deal, is in electricity, unlike in physical situations or physics situations or anything where you're dealing with regular matter, is now you have electricity that goes forwards in time and you have electricity that goes backwards in time. You have electricity that exists in space and you have electricity that exists in counter space. So any electrical situation has to have these poles or polarities in order to be electricity. Otherwise, it's just one end or the other. The Philadelphia experiment, being that naval engineering is kind of part of my work, if somebody pointed a gun at my head and said, "You're going to do this, or we're going to pull the trigger," you figure it out. Okay. The first thing I would do is I would get my hands on the anti-mine cables that run around inside the ships. I had a Navy minesweeper to take apart once. Actually, we were supposed to put the thing together, but as usual, human geekdom destroys all projects. So a beautiful piece of naval engineering went to the scrapyard. But this thing was filled with cables. That the purpose of the cables was to make the ship magnetically invisible. Okay?
Glass lenses, which you're all familiar with, focus light. But if you put an X-rays through it, it doesn't focus X-rays. You can move the lens back and forth. It's just sort of darker in the middle and lighter on the edges, but it doesn't focus X-rays. There's something happening because the X-rays are even smaller or doing something.
Well, according to Tesla, Tesla insisted the X-rays were not transverse vibrations, so they couldn't be influenced.
Yeah, but they're all electromagnetic radiation.
No, they're not. Tesla said that X-rays are not electromagnetic radiation. And there's a big controversy over that. And two whole systems of X-rays developed, the Tesla system and the General Electric system, developed where Tesla could stand in front of his X-ray tubes and not be killed, where if you stood in front of an equivalent X-ray tube of the GE design, you went to the grave.
Well, what is the difference between the Tesla X-ray tube?
Well, that's kind of right now out of the scope of the conversation.
Yeah, but
nobody really said.
Because X-rays are done by slowing down electrons or slowing down.
We'll get in. I'm going to try to get into the electron. That's Tesla. I'm trying to get to Tesla's last discovery, but there's so much. I got to kind of stay on a certain path.
Yeah, okay.
I can't just give a 8-year college course in a matter of an hour.
Yeah, but this next question is much more simpler. It relates to the Tesla thing. We have a device, which I don't know if you've ever heard of a thing called a toroid.
Yeah.
Which is I often refer to it as a Buddhist, kind of like a Buddha belly with a very large content kind of thing. Because in a toroid, unlike a solenoid has magnetic field that goes outside of itself.
Right. Open circuit. Toroid's closed circuit.
Completely satisfied and very content kind of device.
Right.
Which has all the wires go around completely around a circle and nothing sticks out of it.
The natural form of magnetism.
Yeah. Well, now this. The thing about it is you take a magnet, you say you have a large toroid, and it's energized by 60 cycle 120 volt, it's like half of a variac or something. Mm-hmm. If you put a magnet in and around the thing, the magnet does not vibrate because there's no magnetic field.
No external magnetic field. Right.
Contained within the body of the toroid core. Now, what is going on when you take a wire and you run it through the middle of the thing, which has got no magnetic field, and around the outside, a heavy gauge copper wire, and you short the wire, you're forming a loop that goes through the middle of the toroid and around the outside, and the wire gets hot, and the Buddha belly, the Buddha gets angry because now it expresses anger into the wire. But it's not, the wire's not immersed in a magnetic field. It's because the magnetic field is only going to the core.
Well, the magnetic field associated with the wire has to expand out into the core. In other words, the lines of force of magnetism around the wire are concentric circles, and the core's got so much permeability that the circles just stay in the core. But there's a thing about magnetism, so you're bringing out, is that the physical relations of magnetism as we use them don't add up.
Yeah.
And you just pointed that out.
Yeah,
They don't, the toroidal core, it doesn't add up.
Yeah.
There's some way that, and that's where this counter space comes in. There's some way that the wire, see what you're describing, what you've done is you've made one turn around the toroid that's now shorted out.
Yeah.
Okay, when you do that, the magnetism can't, that's what I'm going to get into, magnetism can't get out of the short, it's trapped. In other words, if I have perfect wires, okay, and I got current flow and I jam those wires together, the magnetism that's stuck in between those wires can't get out because there's no resistance. There's no counter space to eat up the magnetism. It's stuck. That's the classic zero, what do they call it? The absolute zero thing, where you take the lead disc, okay, and you drop it through the liquid helium and let it get cold. And when it gets down to absolute zero, because the intermolecular stuff can't interact with the electricity anymore, it will float on the magnetism because the magnetism can't get through it. But the thing is the magnetism is not going through the wire like it's spreading out into space. What the magnetism is going into the wire, into an inner space, a counter space. See, that's what I'm trying to get at. In order to understand electricity, you have to have an understanding of counter space, or it's impossible. And you have to be able to deal with a situation where things are coming from the future into the past, as well as going from the past into the future, because the electric wave you're working on is the point at which all these things cross in space and time. Tesla found out a way to get out of space and connect to another dimension, and Alexanderson figured out a way to circumvent space completely, or his work implies that you can circumvent space completely and make things appear in one other part of the universe without anything time delay in between. Now, if I want to talk to Alpha Centauri, I sure in the hell am not going to use waves that propagate at the velocity of light, because that would be stupid. Okay, now in order to use Tesla's waves, I would have to have an electrical permeable medium of such capacity that it could handle the flux density to carry the power from one end to the other, and that wouldn't be a likely situation between here and Alpha Centauri. So the only thing I could do was build electrical devices that responded in a scalar manner with regard to space. That way I could communicate with distant ends of the universe without having to wait for the signal to get there.
This is where the Alexanderson models.
Yeah, and the integratron. The Alexanderson model, because you went through this and me down there, the Alexanderson antenna is an analog computer of that situation. Now what I'm finding is, which is striking with these analog computers, is not only can I get the waveform or the mathematical function, but I also get the physical effects without the Tesla coil, without the Alexanderson antenna. That is what I would have never expected. And that's what's fascinating, because you might not even have to build all this stuff. All you need is a box full of coil capacitors. You have this big installation, Livermore Laboratories, the big government laboratory.
Right.
Big shot government laboratory. And out of the whole fusion era came this holy grail of producing electricity by hydrogen fusion, which didn't throw out all this garbage and crap like fission does. It's more of an implosive, self-contained type of thing. All the billions and billions and billions of giant magnets and lasers, 220,000 volt power lines on towers, 150 feet high, insulators 20 feet long, big giant flows of money, gas, electricity, and glom pouring into this place, all for one simple engineering premise. They wanted to make a fireball stand in space. Okay? Well, nobody seems to be able to do it. Well, when I was living in the bushes in Bolinas, there was a deranged guy that lived in a house next to the bush. Okay? His name was Philo Taylor Farnsworth III. So I began to get drunk and stoned with this deranged man, okay, and was told that he's really off his rocker, okay, and nobody wanted to even bring me near him, and I didn't know, and I looked at his facial features, and I go, well, he's got to be a Farnsworth. So at any rate, we get drunk together, and the first thing, the drunken mentality, along with all, the foul language and puffing up like frigate birds. My transmitter put out more power than yours. And the whole thing, it results in that I tell him one of my best stories, which happened to do something that created the beginnings of a fusion reaction. What we used to do when I was a kid is the science club was kind of also the pyromania club in those days. Janet Reno wasn't invented yet, okay? So weird things would happen. So in the course of experimenting is I could get all the old tubes from RCA. I had moved a 10 kilowatt transmitter from RCA into my parents' garage. Okay, this thing was the terror of the neighborhood. Well, I found out this terror spread a little farther than that. So what we did is we get these big tubes, back in these giant globes, and of course the ones that were good, were very carefully taken care of. But the ones that were no good, if you still could get current through them, okay, as my parents once a week would go out to a movie or something like that. So the whole science club would show up to my laboratory, okay, and we would play Nuclear Meltdown. And this is what playing Nuclear Meltdown was. We'd take the tube, okay, we'd hook it to the big 3,300 volt switchboard. This thing's got about enough juice to run a whole neighborhood. It's clamped right where the wires come in off the meter, on our side of the meter, but nevertheless had to be clamped right on. It just draws so much power, the whole neighborhood would just go into a brownout every time the telegraph key was hit. So it was a 3 or 4 person operation. One man controlled the plate, one man controlled the screen, one man controlled the control grid, and somebody kind of had to deal me with the whole, to get this thing hotter and hotter and hotter and hotter. Okay, and the thing, all of a sudden would go at some point and would take off, and all the meters, the big Frankenstein switchboard, all the meters would go backwards, okay? And the bravest guy had to have his hands on the abort switch to interrupt this sudden explosion of electricity that would be created in this process. Just briefly, there'd be this sudden explosion of electricity. Well, it turns out to be fusion reactions of this type are very heavy microwave emitters. And I learned when I got in the Navy, every time we did this, it jammed out all the radars in Hamilton Air Force Base. So when I told that to Philo, he was just completely bent out of shape. He couldn't have a better story than that, but he had to. So he disappeared into his bedroom. It was a typical madman, house of boxes, books all dusty, piled to the floor, the ceiling. You couldn't turn the TV off because of the weak cathode, so you put a piece of cardboard in front of it. The inventor of TV's son couldn't fix his own TV. It was a madhouse place, Lots of bottles of wine going down in his guts all the time. Drugs I've never even heard of before. But at any rate, that's where the action. When you live on the street, you're more tolerant. So he goes into his room and he pulls out this screwed up cardboard box, about this big. And he dumps it on the table and he goes, well, you're so smart. Tell me what these are. And I go, what do you got here? He goes, these are my father's tubes. Okay, well, I knew about the TV, but these weren't TV tubes. Okay, so I pick up the tubes. I've been playing with tubes since I was 6 years old. My grandmother used to build them in RCA. It's just in my genes. I look at these tubes, and these things they're crazy. Anybody would say this is insanity. Okay, big giant grids, but no cathodes, and like electrodes sticking out of the side, and all this stuff, and but the thing is, I know how to make tubes. So I'm looking at him, and I start to see what's going on here. And he's sitting there. Remember that cartoon character of that dog that would laugh with that kind of horse after the dog screwed somebody that screwed him? I forget the character. That's exactly how Philo laughed. It was that kind of... You couldn't really hear. It was kind of like a growling inside. He was content. So I pulled this one tube out, which was just an empty quart of glass, and it had an umbilical cord, so to speak, that came off of it to pump all the air out during operation. It was a laboratory tube. They broke it off the pump and discarded it after the experiment. It said 2 little metal shells pointing at each other, kind of like 2 little mirrors. coated with some kind of crappy looking stuff, silver cesium oxide compound, and a simple ring in the middle. Well, it's a simple, electrostatic focus tube with an anode in the middle, and the two plates, and little tiny wires came in because the voltage was so high. I guess it had to be oil or something around. It looked like it operated about 100,000 volts, which is a lot for a small tube. But I look at the glass had been all attacked by something. So it used to be in the old color TVs, there was a certain tube that shorted out the high voltage so that it couldn't get out of control. It's called a shunt regulator, 6BK4. And they glow every color in the rainbow and make the TV repairmen sick. And what it does is it turns the glass, the radiation turns the glass on the tube chocolate brown. And that's how you can tell how long the tube's been in the set. So I'm looking at this glass, and it's like all baked by some kind of incredible electrical activity that couldn't have come through those little tiny wires. So I go, Philo, something took off in this tube, didn't it? Then he stopped laughing and got all crappy with me again. I go, Philo, tell me what happened in the tube. And so he told me I could see what happened. What happened is and this is about 1932, is Farnsworth was working with a radically new vacuum tube technology that did not use any of these glowing cathodes or any of these emitters. The patent situation back then was such that RCA owned radio. You couldn't build anything. That's what started in Bolinas with the Alexanderson system. Lit this thing up, a star appeared in the middle, turn off the power, and it stayed there for a brief period of time. So that changed my life forever. So here you have this giant laboratory and all these billions and billions and billions of kilowatt-hour dollars being expended and all the grooviness and frigate bird activity that goes along with it. And here's some guy in a laboratory on Green Street in San Francisco, okay, on a poverty existence because he's never got anything out of television, does the same thing in an empty bottle, for so to speak.
Where are the two now?
The Farnsworth family still has them, but it doesn't stop there. So what happened is my first laboratory got destroyed in San Francisco, and that's when I lost most of the RCA equipment. That's all based on the campaign slogan, Diane will make a difference. So that's when San Francisco basically swirled into the outgoing tide. So my 8 cents a square foot went to $1 a square foot. So now how are you going to move tons of switchboards 15 feet high, transformers that weigh 4,000 or 5,000 pounds? Commonweal already smashed the rest of it at RCA. The Park Service got my warehouse at Fort Mason, Pier 3. So everything went to the dump. And it was time to eat out of garbage cans again for another couple of years. So what I did is I made friends with a high school kid up there in Bolinas who was a prodigal genius type thing that Philo had trained at an early age. The kid was a genius beyond belief in a lot of different areas. He started hanging out with me. So we built a laboratory in this bedroom. So what I did is I took some of the remaining pieces from RCA and configured them. I decided, well, there's nothing else to do with this stuff other than make a Tesla coil. But make it the way Tesla decided to make it. At any rate, to make a long story short, we worked with this and experimented, went out to RCA, got more transmitter parts because, I could always go back out and get more because the station was still operating then. We build this thing. I take old burned out street lights. We're using the experiment. We get dumpster loads of them from Lease Light in San Francisco. The street lights off of Van Ness Street. They pull them out every certain amount of months. And there's a whole dumpster full of them somewhere. There used to be. We put the street light in these monopolar fields that I just described from these coils. And the street light that we used for this experiment was the one we'd used previously for all of our spark gap experiments and everything. And something had started to transform with the bulb. We put this thing in the field within a matter of a minute or two of working the thing in the field. You have to be careful because they explode violently. Full galaxy appears inside the bulb, just like a picture of one of these Nova TV deals. You can spins, whole thing, the stars, the nebulas, the suns, all the colors of the rainbow is spinning inside a burned out street light and virtually powering and containing itself, which has gone beyond the Farnsworth. Now we have a whole astronomical creation floating around in a light bulb on a workbench, and then it explodes the bulb. But after it explodes the bulb, for like a tenth of a second, it's not long, it sits there without any bulb to contain it.
What is it? What's in it?
That's the creative force. This electrical monopolar field is how creation comes about. There is no evolution or any of that type of stuff. It's the electrical field at the time creates what exists, and it's always changing this way and that way. All living organisms are all based, just like all machines, are all based on the same mathematical function. All trees, plants, flowers, humans, everything's based on what's called the golden ratio. It's a definite geometric pattern, and all of these electrical discharges associated with these Tesla transformers are all golden ratio proportioned and tend to be self-organizing and self-powering. So that ends the story. $1 trillion in the Livermore laboratories, and a deranged high school kid and a homeless person go beyond it in the laboratory. And that's how I was endeared to the Farnsworth family. Because Philo's mother, which was the wife of the inventor, came to the laboratory to see this, and when she saw, that here this is going on with junk and no money, and her husband had devoted half of his life to researching this, then it was time to start being friends and talking. So I had their whole Farnsworth notebooks and everything available to me.
The neutron, does it have mass?
I don't even know if it exists. It doesn't enter into the electrical equation.
The star. You can reproduce the effect that you described, the astronomical emergence. This is reproducible for you?
It's hard, but yeah, it can be done.
It sounds like you did it in a field with some broken stuff.
Well, what I did is I built a radio transmission device based on Tesla's work, and I built a pair of them so it couldn't transmit. It could only focus in one spot. And there's a neutral plane. If you take two monopolar fields and point them at each other, there's this weird neutral plane between them, and it's kind of like an opening into another universe.
What was the frequency of this transmitter?
This one operated, the frequency's immaterial pretty much, but it's got to be an HF band. It operated at 3.3 megacycles.
All right.
The voltage was about 60,000 volts. The electrode area at each end was about maybe 15, 20 picofarads of capacitance. So basically the tube sat between the plates of a capacitor, so to speak.
Did RCA know what they had?
RCA, here's how the whole situation came about. Okay, Marconi robbed Tesla and came up with a completely impedance mismatch system compared to Tesla, but it got around the patents and it kind of worked. He really jammed a lot of juice into it. So he built 5 stations around the world. The pilot station was in New Brunswick, New Jersey, and the first operative steps out of that was Bolinas and then Hawaii, and an attempt to get to Japan. What happened was, being that Marconi was a foreigner, and this war thing was building up, this was around 1913, 1914, the Navy decided that Marconi was going to get the boot. Okay, at that time, General Electric had, through Alexanderson, had finished developing the Alexanderson system. So the Navy had Alexanderson come to Bolinas and reconfigure the whole station to his system with the full embodiment of the patent. In other words, the antenna with the scalar function, not a velocity. The whole thing was built there because the space was so small. New Brunswick and Radio Central in New York had all the space in the world, but Bolinas was so small, and it was RC. What the Navy did is once Bolinas, the plans were drawn up and things were ready to go in, the Navy formed the Radio Corporation of America to take over Bolinas and New Brunswick and be the rulers of radio. The Navy, particularly this Assistant Secretary of the Navy, Franklin Delano Roosevelt, decided we must even go farther with this and outlaw radio completely. And it was illegal to own a radio in 1919. Basically, 1919 is a signal year for the death of electrical engineering. RCA was formed. They formed a patent pool and a trust. Nobody could build tubes. Nobody could build transmitters. Nobody could do anything unless RCA decided it was to their behalf. Okay, well, the integratron is, that is what I regard would be the physical manifestation of the scalar transmission. In other words, that's the device If you have one on Mars and you have one on Earth, if you go in the one, you walk out of the other. That's when I studied that.
Was there one of those in Lancaster?
No, there's none of them around anywhere, really. About the time I figured out how to make it all work and found that all the materials were there and the whole thing was kind of set up like a Heath kit, and I managed to get all the junk and the weirdos and everything out of there and all that, well, lo and behold, the guy that had the property lost it and everything disappeared. So the Soviet scalar technology hoax is mainly the work of an Army colonel, I believe, by the name of Tom Bearden. And it's exactly what it was. It was a hoax. It was designed basically to throw so much confusion into Tesla's work and to absorb up all of the Tesla Society meetings and the psychotronic meetings and everything and create this paranoia and fear and then make money of selling devices to protect people against the non-existent waves. Because scalar means there's no wave. So if I say scalar wave, it's kind of like saying an Israeli-Palestinian. I mean, it's one or the other, you know. If you can't exist. Scalar is that part that doesn't vary. That part in which there's no wave. That's why it's called scalar. It's a quantity with no direction in space or time. No divisions, no variation, no distribution. It's that part that's everywhere, the same. A good example would be atmospheric pressure. Okay, if I take a barometer around this room and out in the street and all that, the barometer is always going to read, let's say, 30.1 inches. Doesn't matter there, here, any of that. Okay, I could take it up to Haight Street. I could take it down, you know, as long as I compensated for the altitude. You know, it's always going to be that air pressure wherever I go if I can maintain a certain altitude. That's space scalar. There's no variation in space. But if I graph the atmospheric pressure over a week, I get these like sine waves. So atmospheric pressure is scalar in space in the neighborhood. Obviously, if I go to, you know, Eureka, it's going to vary. But it's, in our area, it's scalar in space. But it has a wave in time. Does that give you kind of an idea what the word scalar means? It's that quantity that, it's like DC. If I take an electrical oscillating system and it's got impulses and it's got oscillations and alternating currents, there'll be one quantity of electricity that doesn't vary. While all the rest of it's going higher or lower in this way and that way, there'll be one constant that will be uniform throughout the whole circuit. That's the scalar quantity. So what Bearden did was use the trick to take, there's two types of waves. There's longitudinal and transverse. This is the whole bugaboo, and this is what the Einstein thing is disrupted. And this is the forgotten part of Maxwell's. Maxwell considered two types of waves. One is transverse. Okay, a transverse wave is like waves on the surface of the ocean. Okay, there has to be a boundary. And the motion of the matter or the ether or whatever deal you're dealing with is always at right angles to where the wave is going. Okay, and it's slowed. It tends to circulate and stay in one area and then move on to the next and move on to the next and move on to the next. That's called a transverse wave. In other words, the energy is sideways to where it's going. You understand what I'm saying there? Does everybody kind of get that? I guess? Okay. Now, a longitudinal wave, if I set off a load of dynamite underneath the water, okay, and then another place underneath the water, okay, it's a shock wave, and that other place gets it real fast. There's hardly any delay at all. Okay, it's right there, and it'll blow your eardrums out. Okay, and the surface, initially, there's no evidence of this until the turmoil gets going. That's a longitudinal wave. Okay, the material or the energy or whatever is going the same direction that the propagation's going. It's in line. Okay, now if I take a 10-foot rebar piece, a half-inch rebar, okay, And they set it on little deals so that, it's free to kind of move around, doesn't fall to the floor or whatever, strings. Okay, what I can do is I can take one end of that rebar and hit it with my hand, and a little wave will whoop sideways, just like a transverse wave will go from one end to the other, right? I mean, that's like you do it with a piece of rope or string. The other way I can do it is I can hit the end of the bar with the hammer. You can't see that wave. It's instantly at the other end. That's the longitudinal wave. You see the difference?
What is a wave of compression?
It's a wave of compression and expansion.
The actual medium of transmission for delivering the force.
Right.
And the other is transverse, involves some other process.
Yeah, so it's a transverse wave is kind of operating out of the wave realm. It's not really a very effective wave. Now, if electricity is supposed to be transmitted through space electromagnetically, the first complication that comes to mind is where's the boundary? There is none. So Tesla said there were no transverse waves. It had to be longitudinal. So right there, then that kind of just messes everything up. This thing about the integratron is my theory. Okay, I mean, I've never built anything where you walk in the one box and you walk out of the other one. But the thing is what I found is this integratron structure had to be space scalar. If you analyze the electric fields that appear, the key to the integratron was it had a pair of coils, 90 turns, and 1 mile of wire on the ceiling of the first floor. One went one way in copper, and the other one went the, got this right? Yeah, the other way in iron. 10 gauge copper, 14 gauge iron, soft iron wire, all insulated. Okay, and there's 4 spark gaps that were remote controllable by compressed air and plastic pipes, so you couldn't have any metal in here to short this thing out. The whole thing was charged up with 100,000 volts from the thing that spins on the outside. Electrostatic generator, and the dome is covered with metal, so that's your capacitor to space. And this thing is inside the flux underneath, and these spark gaps fire into the copper and iron, which juncture in the middle. They fire, 2 of them fire into the ends of the coil, and 2 of them fire, I forget the exact diagram, but 2 of them fire into the dome, and so it's this electrostatic energy is being pulsed into this coil. Okay, where they come together in the middle, there's kind of like a capacitor and a column. They drop things down. What goes in there, I don't know. But when you analyze this, what it comes out to be is it's a strictly space function. There's no space variation. So what I did is I did some experiments, because Van Tels was always talking about caduceus coils. That's a coil where you got turns one way, and then compounded on it is turns the other way. And what I found is if this is coil A, I might have it wrong, but from the outside it'll look right. This is coil B. Okay, if I connect them in this way, okay, at these terminals, because this thing will resonate in an inductance capacitance oscillation, but the amount of capacitance, the amount of inductance here is all screwed up by the fact the turns are wound backwards on each other. This thing will oscillate at a frequency of roughly 100 times beyond the wavelength of the wire, and with a precision that's so intense it makes you wonder, like, what's it locked into? And somebody had tried this idea and came up with some UHF TV antennas built on this principle, and the receiving range apparently is fantastic. So this is the key to the integratron, is to create this space scalar condition, where it exists only in time and it doesn't exist in space. And that started to give me the idea that maybe this thing wasn't for healing people, but for making people be able to go from point A to point B. And then the Alexanderson space scalar concept popped up later in my study of RCA, and so that kind of serves as again as an analog to this space scalar situation. So if somebody wants to start experimenting with, building a transporter, it's not a matter of taking the molecules apart and making them reappear at another end. That would be a hideous project. Doesn't make any sense. The best thing to do is just simply erase space out of the formula so that you're both places at the same time, and then make the switch, turn one off and leave the other on. That's how I perceive the integratron. Allegedly, How many people here know what the integratron is or heard of it? Okay, well, here's the integratron for the people that don't know. Okay, there was an old German guy that lived under a rock out in the desert. Okay, and it used to be a place where things would appear in the sky. It's called Giant Rock. It was a giant rock. Old German guy lived under it. It was in San Bernardino County. Okay, this was during World War II. Okay, the German guy had a big shortwave antenna, and his, Atwood Kent, with all the tube radios and all that. So for some reason, the Riverside County Sheriff's Department decided that he was a German spy, and they killed him, blew him up in his hole. Well, Van Tassel had been coming out to visit this guy to hang out because that's the place to see the weird stuff that flies around in the sky at night. So Van Tassel just inherited the place because he was there and nobody else was, and it was the deep desert. And he was an aerospace worker for Howard Hughes on a personal level. So he was into the whole kind of, spacecraft and all these. Because Hughes came up with some really bizarre stuff you don't normally hear about. That's probably why he was put out of business. Hughes was deep into this stuff, experimenting and what have you. He was a genius of his own right. So apparently Van Tassel and his son-in-law were approached by a spacecraft. Okay, and the aliens gave them instructions to build this integratron device. And they went forth and started building it and, started having these conventions and turned the whole thing into a dog and pony show. So the space people cut them off. So they carried on the dog and pony show until eventually everybody kind of died off, and that was the end of that. And then the geeks ended up with it. So you had the Purple Gay Indian Club, and then you had the bikers, and I don't know how much meth might have been cooked there in various phases. It looked like it might have been a lot of LSD. So my job as the exorcist, that's one of my positions in life, is I go in and I run the devils out. So without a shot being fired, I got rid of all of it. And then once all the junk was gone, and I was introduced to all the people that knew Van Tassel, and I read everything he wrote, I went around and found all the little pieces here and there. I found once the mess was cleaned up, here was a Heath kit. The boxes of wire, the aluminum for the dome, was all lined up right there on the floor, ready to go.
That's big rock right there.
Giant rock.
Giant rock, yeah.
So what I did is start to put it together, and with 6 months, gee, I wasn't there anymore. And all the equipment disappeared.
And they filled in with concrete as well. They made sure.
Well, no, the dome is still. This has been, the Park Service. There's no more under the rock.
Right.
And then the rock split in half. I think that's what you're seeing there as the piece broke off.
That's right.
So we decided we were going to plant some rumors around there that there were some people buried under the rock and name it after the people that didn't really exist.
Yeah.
Something derogatory, because that place now is just a haven for motorcycles. And I haven't been there in 20 years. You can't see the stars out there anymore anyway. So that's basically what the integratron was about. So now these people have it under lockdown, just like they have the Bellina station under lockdown, everything else under lockdown. And it's just become another self-worship temple. So that's the end of the integratron. But that doesn't stop people from building models and experimenting with this stuff. No, what I did is I took a relay coil, which had about 1,000 turns of wire in it.
Very good.
So it could absorb up the magnetism to the point where it would drive the headphones. It had a magnetron magnet. I took the coil and moved it around the magnet, and I could hear the magnetic field scraping through the coil.
There would be the
Scratching noise.
Okay, so
The lines of force.
which you interpreted as like real sharp transients, saying this is not a smooth continuum.
No,
These
it's
are really
fibrous.
Sharp boundaries.
It's fibrous.
You could do that again, probably.
Anybody could do it.
So that would make a great introductory class lab.
Anybody can, that's the whole thing, is to experiment. What I did is, I didn't have any, college professor or anything. I was just a kid. Main thing I wanted to see was big sparks. So how's a little 6-year-old junior going to get big sparks? So, it's a different way of studying when you're a kid. You're going after more, I don't know, you're better off that way because there's no preconceived notions. That's why Tesla and all these people could make these discoveries, because the mind viruses weren't established yet. They could move freely. There was no unit of the Henry and there was no unit of the Farad when Tesla built his Colorado Springs project that had just been developed. So when you read these guys' books, you have to go use their system of units, CGS system of units. The volt and amp, see, all those things are all recent ideas. But the original guys weren't hampered down with all these like definitions like now. They were able to move freely in it before it became rigidified as a corpse, like electrical engineering has become today.